All right, kind of a review, right, Fabiana? We've said this, and you know I like to do this as we go along so that I've said it more than once. The sun is the main source of energy in an ecosystem. If you don't think that you won't see that again, you are wrong. I am literally telling you that is like one of the questions that comes up on the benchmarks. It comes up on the EOG, and it'll most definitely be on my test. And you'll see that same question when we start talking about the water cycle as well. The sun is the main source of energy. Why is the sun the main source of energy in something like a food chain, a food web, a food pyramid? Well, that's because the beginning of a food chain, the beginning of a food web, the beginning of a food pyramid all starts with producers. And producers goes all the way back, Jesse, to like one of our first vocabulary words. What is a producer? It's what? A plant. And what do plants do? How do they make their own food? Using the sun, right? So that's why the sun's the main source of energy. If the grass, in this example, cannot make its own energy, it can't pass energy on to the grasshopper. If the grasshopper has no food to eat, it can't then pass on energy to the bluebird. And if you start to look at this slide, you're going to see words that you are now familiar with after yesterday's lesson. Producer, there's that word. Primary consumer or first level consumer. Secondary consumer, third level or tertiary consumer. Here's our fourth level, quaternary consumer, or what they consider in this food chain an apex predator. And then anytime any of these die, anytime any of these poop, decomposers do their job and they break down that organic material into good soil, which then helps the producers continue their cycle. Now, when we talk about food chains, this is the one thing, Anna, that I think most people kind of have a fairly good grasp of. Mr. Bullens, I've got a food chain. Food chain is very easy. Grass to grasshopper. Grasshopper gives energy to the blue jay. The blue jay gives energy to the owl. And most people don't struggle with that. So people don't necessarily, they don't struggle with what is a food chain. They don't struggle with identifying a food chain. And they typically don't struggle with identifying if somebody says, in this food chain, what is this organism? And people go, oh, well, it eats grass, it's an herbivore. Most people don't struggle with that. What they struggle with is the questions that say, like, in this food chain, what would happen if there was an increase in bird populations? Because people don't take time to draw it out. So if there's an increase in the bird population, that means the birds are going to eat more grasshoppers, which means the grasshopper population would decrease. And if there's less grasshoppers, that means the grass would increase. Or yeah, it could exceed the carrying capacity. It could dry out in a lightning strike, and the next thing you know, you have a wildfire. So you see that all of those animals, the different populations, all have a role. They all have a niche that they fill, right, to keep the ecosystem in balance. And it's important to be able to understand all of those things. Don't worry about that. Food chains we've gone over, and we've gone over these slides enough. And if you go through these at home, it is important that you kind of practice this. What would happen if? And we'll have a lot of those to practice before we take our first big test, because that's the thing that's going to be the toughest on us. So I'm going to go past all these. Food webs. What is a food web? Well, a food web is an overlapping food chain. If it was just grass to rabbit to fox, food chain. Very easy. That's a very simple food chain, right? But let's be honest. Again, Max and I go outside with our science journals and we start looking at the grass outside. We're going to realize real quick that it's not just the rabbits that come out there munching on the grass, right? The sun gets a little lower, it gets close to dark. Who comes out of the woods? The deer and all her little babies, because it's kind of safe at that point. Plus, it's a lot quieter when you kids aren't here. And they start munching on the grass, right? And then we start to hear all of these, like, crickets and things at night. They're munching on the grass. So we're going to see more than one animal eating the grass. If we could get super small, we might see these mice and rodents eating on the grass as well. So again, it's not normally just a food chain. In an ecosystem, you're going to have a food web, overlapping food chains. And I think we've practiced with those a lot. We'll have a chance to kind of go back and look at some of those. Yesterday, we talked about the food energy pyramid. The food energy pyramid. Now, again, this food energy pyramid is literally like if you took a food chain and kind of turned it to where it was like pointing straight up, right? Because no one in here is shocked by grass to rabbit to snake to hog. Like, oh, Mr. Mullins, that's a food chain. That's easy. That's all a food pyramid is. So in a review from yesterday, we remember that producers make up the base of the pyramid. Why? Because the base of the pyramid is the biggest. And in an ecosystem, there's more producers than anything else. Why is that true? Well, you can't have more lions than zebras. That wouldn't work out very well, would it? You can't have more zebras than you have grass. That wouldn't work out. This is the beginning of the food chain. It has to be the highest amount. So there's more producers. And what eats producers? Herbivores. That's straight vocabulary from last week, right, Collins? But we call this first thing, this grasshopper, the first thing to eat, a first level consumer. Primary consumer, right? First level consumer. And I think that's easy because I can easily remember, Fabiana, first level, second level, third level, fourth level consumer. That's easy, right? Because it just keeps going up. The first person to eat, the second person to eat, the third person to eat, the fourth person to eat. But we know that science loves to throw these fancy words in here. So a bird will eat a grasshopper. That was in our old food chain, right? The bird is the second thing to eat, so they call it the secondary consumer. So these two are very easy. First level, secondary. The words are literally the exact same thing. It's when I move to the bird to the snake, when they don't call it the third level consumer, that it gets a little tricky, Hayden, because it's called a tertiary consumer. If we remember that word from yesterday, tertiary consumer. And the snake is eaten by the hawk, the apex predator, which is called the quaternary consumer. Now, if you can't remember that, there's a couple of ways to remember that. The QUA is the first part of quad, which means four. Or if you count to four in Spanish, uno, dos, tres, cuatro. Oh, my goodness, there it is right there, right? So it's easy to remember. So the only one that you really need to kind of remember is tertiary, but it means the third, and it starts with a T, so we'll be good to go, right? Now, don't stress, all right, Veda? I'm not going to sit here and try to slap these words in a thing, but explain the tertiary consumers. These words will pop up in questions, and I don't want you to get confused. If you're taking a test in my room and this word pops up and you just don't remember, raise your hand. And I'll say third level consumer. If it pops up on a benchmark or an EOG, it can't help you. So I'm hoping it kind of sticks in your head. Everybody feel good about that? All right. All right, so that's a food energy pyramid. We went through all of this yesterday. And I'm not going to go through all these slides again. You have access to these slides if you need to go through them, but we just reviewed it just now. And we're going to skip that. Limiting factors. Give me a big thumbs up if you saw that vocabulary word this week and you're kind of looking like, ooh, that was a little tricky. All right. A limiting factor is anything that can control the growth or the survival of a population. So let's take the plants outside. What are things that might have an effect on the plants growing? Well, we can look in the window and already tell you some of those things. Sunlight can be a limiting factor, right? Too much sun, will it limit how the plants grow? Not enough sun, will it limit how the plants grow? Sure. What about water? Absolutely. You can look in the window. If you don't get any water, you're not going to grow. The ones that we didn't water haven't grown at all. So does water limit how well plants grow? Sure. What about soil? Look in the window again. If you look at the ones that have water and good soil, they're all growing. If you look at the baseball field, dirt, nothing's growing. So soil can control the growth of the grass. What about if we added 75 deer, do you think that would control how well the grass is growing out there? No. It would, because they would eat too much grass, wouldn't they? Yeah, it would limit how much grass you have. So, again, if we were to have some kind of a disease that killed grass, could that limit how well the grass grows? Yeah. So a limiting factor really isn't anything crazy. If you have too many lions, it will limit the amount of zebras. If you don't have enough lions, the limiting factor, you will start to exceed the carrying capacity in that area. Pretty easy? I think limiting factor is easy. Now, again, don't stress this one. It's not one where you're going to have to answer like 55 questions. But Cameron, just in case it pops up in a question, I want you to understand what that word is, all right? So again, just as a review, Anna, if the temperature is too high or too low, it affects the growth and the amount of animals and plants in an area, right? It just does. If it gets too hot in the Arctic, it's going to limit how many polar bears survive, isn't it? They can't survive if it's not cold enough. And then if the ice starts melting, then they're not going to have as many places to stay, and they're not going to make it. Here, if it's too cold, the plants wouldn't make it. They're not adapted for it to be cold all the time because we're used to 4 seasons in a deciduous forest, which is where we live. So, as Glenn was thinking about this sickness that spread through all the bears, and he started putting together like, oh, that's a limiting factor, right? And we could put that limiting factor question into a food chain, right? What would happen if the bears decreased because of a limiting factor of a sickness? Now there's not a lot of bears left, and that puts us into this new vocabulary word of threatened species. When you are threatened, that means you are in danger of becoming endangered. And I know that that's hard to say, and I'm not going to lie, like, Mackie, that's kind of hard to wrap my head around until I learn the next definition, which is obviously the next thing. But a threatened species, it's not good when your species is threatened. You are in danger of becoming endangered. All right, so we've written down the definition, a species in danger of becoming endangered. We know that that's the first step in a population really starting to decline. We'll come back to that in just a second. Whoops. Another vocabulary word. If you have moved from threatened, like we said with the bears now are down to 250, Ashley. You are no longer threatened, you are endangered. Now here's this word, danger. Whoops, I didn't highlight it all. Anger. Oh, that's anger too. I don't like it when things are in danger. You are endangered. There is a danger, that means something bad could happen, right? There is danger. That means you might go extinct if things don't get better. And Fabiana, like I said, you don't wait until the wall is falling to fix it, do you? When we hit endangered, there's too many times that we get to this point that we can't catch all the bricks from the wall and put the wall back up and the animals go extinct. In your lifetime, if I showed you the amount of animals that have gone extinct, it would probably blow your mind. And there are some that there's like only one left. There's a few rhinos. There's only one. Well, if there's only one, they can't have babies. When that one dies, that's it. That's kind of sad to me, right? Check out this Amur leopard. There are only 6. This is when I made this. I'd have to go back and look at the population count now. When I made this slide like 2 years ago, there was only 60 left. It's possible, I won't type it in now, but they could be extinct. That's kind of a scary thing to think about. If you are endangered, you are in danger of going extinct. All right, so we just looked it up online. There's actually 100 left, so the numbers have gone up, which is good. So we'll have to update this slide. If the species has completely died out, there are no more of them, we label that as extinct. The western black rhino was declared extinct in 2011. That is all the notes for my people at home today. Smash the like button, click the bell for notifications, and later.